Assalamualaikum and hi. In this video, we're going to solve a problem related to particle physics. To be more precise, it's about particle decay. So let's take a look at the question. A stationary particle 1 decays into particle 2 and 3. Here, you can highlight the stationary particle 1. It doesn't state what kind of decay it is. Is it pion decay or whatever? I don't know. Here, we have to show the kinetic energy of K2 of particle 2 is given by this. And E1, E2, and E3 are the rest energies of the particle. So E refers to the rest energies. How do we start solving this kind of equation? We have to look back at the concept of conservation of energy and momentum. We're going to use this formula a lot. This is derived by the classical momentum equation. The difference is this time it is particle physics, not the classical physics anymore. So let's move to the proving.
Before we start proving the equations, we need to understand the problem first. Particle 1 decays to become the particle 2 and 3. According to the conservation of energy principle, Q equals to K2 plus K3 equals to E1 decays to E2 decay and E3. How to start this? To start proving, you have to rearrange this equation. You want K3 to be with E3, and K2 you want to put it together with E2. So let's rearrange the equation. K2 plus E2 minus E1 equals to negative K3 plus E3. What matters is this particle 3 are sitting together with particle 3 also, kinetic energy from 3. Oh, I forgot to tell you that E stands for mc squared, which is the rest energy. The next step is you just square this side and this side. This is not binomial, it's trinomial. So if you still remember how to expand it, then it's good for you. If you don't remember, let me show you. Let E2 minus E1 equals to x. Alright, it's easier for us to expand it. And then you're gonna substitute this E2 minus E1 to x. K2 plus x squared equals to negative K3 plus E3 squared. This one is you just gonna expand it like the usual things. K2 squared plus 2K2x plus x squared minus this is like a little bracket here, so don't forget this negative sign here. So it's gonna yield to K3 squared plus 2K3 E3 plus E3 squared, right? So once you get this, you're gonna substitute back x with this value. So K2 squared plus 2K2, x is E2 minus E1 plus E2 minus E1 squared equals to, okay, you're just gonna write it back. I'm sorry, my writing is messing me up. Okay, the next step is you're just gonna expand the whole thing. This one expanded comes 2K2E2 minus 2K2E1 plus this one is E2 squared minus 2E2E1 plus E1 squared. Write it back. K3 squared plus 2K3E3 plus E3 3 squared. Alright, referring to the question, particle 1 is at rest, so we don't wanna equate the particle 1 in this next equation just because it's at rest. So we want to include particle 2 and just particle 3 only. Okay, we're gonna find the same pattern between particle 2 and particle 3 according to the conservation of momentum theory. You're gonna have to write this: bc squared equals to k squared plus, this is the main this is the main equation for conservation of momentum, k squared plus 2k mc squared. Notice that mc squared equals to e, right? Okay, so we're gonna write it again: k2 plus k squared plus 2ke. You're starting to see the pattern here, so you're gonna take all the k2 and e2 into one equation. Is going to be like this: k2 squared plus 2k2 e2 plus, we're going to rearrange this equation from here, plus I'm going to put a bracket here so that you can differentiate between what matters and what's not. E2 squared minus 2k2 e1 minus 2e2 e1 plus e1 squared equals to k3 squared plus 2k3 e3 plus e3 squared. Alright, here you just want this equation to equate with this equation. In proving an equation, you can ignore this because you know that particle 1 is at rest, and then we're gonna prove between here and e3 squared here. Now let's do it. E2 squared minus 2k2 e1 minus 2e2 e1 plus e1 squared equals to, remember we're gonna put this aside first, so equals to e3 squared, right? I'm going to rearrange the equation. Let's do it. E2 squared minus, you're gonna put e3 here, e3 squared minus 2e2 e1 plus e1 squared equals to, you're gonna bring it to the right, 2k2 e1. You want to prove k2, so okay, let's see this pattern here: e2, 2e2 e1 and e1. What is this? If you remember, this is the pattern of quadratic equation, so it's basically e1 minus or plus minus, right? Minus e2 squared. You factorize these terms here, you factorize to become e1 minus e2 squared, and then minus e3 squared equals to 2k2 e1. When you reach at this point, you can happily move this e1 and 2 to the bottom of this. Right, you're almost done. E1 minus e2 squared minus e3 squared divided by 2e1 equals to k2. So this is the final answer. So you're done proving the kinetic energy. Actually, if you notice about this question, the physics is just here at the beginning of the question. You're going to design the equation according to the problem stated. if you don't understand the physics here, you can't come up with this type of equation, and the rest are mathematics. So see you in the next videos.